Greetings and welcome to this installment of Introduction to Solid Modeling using SolidWorks. So far we have made a number of parts and assemblies and drawings, and now we're going to put them all together. We made three sets of tools. We have a saw, a crescent wrench, and a screwdriver with several bits that go along with it. And now we're going to put them into this storage board. Now the storage board, a very important aspect of it, is that it's designed to be injection molded. And so what we want to make sure is that it can come out of an injection mold which has cavities. Now it's hard to explain this, so if you don't understand injection molding, you should probably look up on a couple of other videos online. For my design, there is part of the mold that comes from the bottom and goes out this way. So from this perspective, it would be going to the left and another half would be going to the right. So this cavity goes this way, this cavity goes this way. Because of that, the geometry involved must allow for that kind of work. That's why, for example, I have spots for the bits right here, but I couldn't put the other spots for extra bits up here, which made more sense in terms of use. I had to put them here. If I put them here, there's no way to get that cavity out coming this direction unless you increase the cost of the mold dramatically. The way I have it designed, all you need are two halves. Now, one might ask, well, why didn't you pull it out left to right this way, going out this way and out that way? Well, the main reason is that where I want to hang my saw here and my crescent wrench here and my screwdriver here, I wanted to have some kind of lip or other way of making sure they stayed there instead of falling off. So the way I did that was, well, I could have put a lip here. That would have ensured that you couldn't pull left to right this way. So a lip here would have made sure that the saw stayed on, but that you couldn't use a mold cavity going right left this way. What I did instead is I made it simply a slant, so that if I had made a lip, that lip may have been broken off, but I slanted that surface and this surface and this surface down here, which made it impossible to use a simple mold that would go left right this way. So it ends up being possible to go left right this way. Well, there we go. Something like that. So down this way and up that way. So how did I make this? Well, there are a couple of things that I wanted to make sure that we covered before we got done with all of these parts. So if you're wondering, why did you design it that way? It's probably because I just wanted to hit some of these other parts. One of the main things I wanted to cover for this particular part is how to extrude a thin feature. Well, if you think this is a block, well, it is kind of a block, but the only sketch I made was a single line. Look at this. That's it, one line segment. And I made it a thin feature. So what happens is that the feature itself gives the other two dimensions. And I made it so that it was going a certain amount one direction, 150 millimeters this direction, 130 millimeters that direction, and 3 millimeters thick. Now, that's another thing you need to know about injection molding of plastics, is that it likes to have similar size, if not the exact same size, wall thicknesses everywhere. And usually those wall thicknesses are best between 50 or 100 thousandths of an inch, or in this case, about 2 millimeters. Well, I made it 3 millimeters, which is a little bit larger, but that can be done. Okay, the next thing I did was I extruded this boss, and the handle shape should look a little familiar to you. because that's what we did. The very first thing was make that handle and learn how to sketch. And then we extruded this thing, very simple. And then we made another thin feature. And if you'll notice, this is a hexagonal shape. And all I did was I cut off the top two parts, made all the rest of these equal, gave it a dimension that was going to work right with ours. And so when you put your insert or your bit in there, it'll squeeze right in. And then offset it from the edge here a little bit and moved it down from where the crescent wrench is going to hang. Then I made that thin feature, and so it just expanded outside of that. Okay. Next I did a linear pattern. Now we've done that before, but then I did a linear pattern of a linear pattern. And then I also deleted a couple of spots. So you'll see what I mean when we get to there. But it was kind of fun. I wanted to show you how to do that. And then we did another thin feature. So I'm kind of beating up the thin features here. And notice I made sure I had a center line through there so that I could make a plane and then make a mirror. All right, now that was all the basic stuff. The next thing I did was I made a draft. This draft is what is making that slant so that when I put the saw back in place or the crescent wrench back in place, it doesn't swing back off. It has to slide back down just a little bit. Nice 5-degree angle. And I put it right on this surface as well. Okay, then the last thing I really wanted to show you was a shell. Now, like I said, for injection molding, you need to have thin walls. So big, thick blocks like this here are just not going to cut it. You'll have all sorts of problems filling that. There will be voids. There will be all sorts of defects every time. So what we do is we shell it. And we make sure with that shell that all of our wall thicknesses are about the same. And that shell, I believe, was about same here of 3 millimeters. Then after that, especially for injection molding, you want to have a lot of rounds. You don't want to have too many sharp edges. It's not too bad on some of the things, but rounds and fillets will simply make it easier for it to come out of the mold. And the filleting on this is challenging, shall we say. One place I did not put it was on these edges here because we might want to push our inserts right down into that spot. But pretty much every other edge has been filleted in this case. Okay, let's start. All right, let's start in on some of these thin features. So going to go to Extruded Boss Base, and as usual, we will consider the front plane facing us directly, say the plane that the board would hang up on the wall. But I'm going to click on the right plane and make my sketch there. And we'll be extruding on either side of it, so going along the front plane there. And dimension that to 50 millimeters. And then I'm done. That's all I need to do for this sketch. And it automatically knows that I'm going to use a thin feature. So what thickness am I going to use? Like I said, I'm going to mold it in 3 millimeters. And I'm going to do it in two directions here. So one direction will be 130 millimeters and the other one will be 150. And I'm all set. Next, I'm going to sketch out the handle. So going to sketch, I'm going to choose that plane. I'm going to face that plane right up and go here, up, and then back down here. Remember that trick we learned? And then coming tangent this way, coming back over here, make that curve like that, and straight down, all the way back over to there. Okay, so going to go, this is going to be 110, and I'm going to bring this part up here. Oh, now it's getting messy. There we go. Going to make this and this equal. Going to dimension that to be 10. From here to here is 15 degrees. Going to keep that same angle that we had before. Gotta bring that up a little bit. Dimension from here up to here. And I'm just going to accept that. I'm going to change it to the maximum. And then make it 35. And still all blue because it doesn't know where it is with respect to the origin, but now it does. 25, and that is everything we need. Notice there's only a little short straight line there, but that's okay. Okay, so now we're done with that. Let's go to Features, Extruded Boss Base, and we're going to extend that out 30 millimeters, and that's done. Next, we're going to make the post for the Crescent Wrench, and it's going to be very simple. Make a 3-point arc here, here, and bring it like that. There we go. Dimension it for radius, and we're going to have it also an inch out. There we go. Smart dimension that to that, and 25 is. It looks like it did not notice that the center is supposed to be on this line, so that makes it easy. There we go. Now it's black. Okay, now I could close the loop here, but I'm going to not and see what happens. Okay, now it wants to ask me if I want to close the sketch with model edges. And if I click on reverse direction, it's going to go all the way around and make a big old mess. So this is an improvement in 2015, but let's see how well it does. Oh, okay, so now we look at that, and it looks like it did actually put a line in there. Did a good job. Doesn't always, so I don't trust it. I usually prefer to close the loop myself. Next, we'll make that go 15 millimeters out. Okay, so light post to put that on. Okay, next, have another sketch to make right on here again, and we will make a hexagon. Dimension from here to here, 6.35. Escape. Make sure each of these sides is equal. Yep. Okay. Now I hold my control key down. Make sure I'm selecting the edges, not the face in the background here. Make those equal. Then I'm going to trim out these entities. Make sure you don't hit the circle. Oh, you gotta hit these two. Okay. So I'm going to go back here, make this vertical. There we go. And do some more dimensioning with respect to the rest of the part here. Put that 5 millimeters up. And this edge. And there we go, that point. I could have used the points here, but because I chose that vertical edge, it knows that I want a horizontal dimension. Just want it 25 again. Okay, now I have that sketch. Click on that sketch, go to Features, Extruded Boss Base, and for once the default 10 millimeters is pretty much what I want. And it knows I want a thin feature, only going in one direction. And I'm going to make this a 2 millimeter thickness. That should be fine. It's a fairly short distance for it to do the mold in there. Okay. Next, we're going to do another linear pattern, and we've already chosen this one. So I'm going to choose this edge here, nice early edge, and want it to go the other direction. Okay, I'm going to use 15 millimeters for my offset, and I want 3 instances, and that's done. And now I'm going to do the linear pattern of the linear pattern. So I'm going to do linear pattern, and I'm going to choose this as well as the linear pattern. And my first direction here, I want it to go, well, I only want 2 instances, and I want it to go like 50 millimeters or something like that. Maybe more than that. Try 75. It looks a little better. Now I want to make sure that this is clear because my cavity is going to be running through this area. Yes, I'm designing a very cheap molded part. So then I also want to go another direction, so direction 2. So I've got that blue field up, and I'm going to click on there. And I'm going to make 2 instances, and there they show up. That'll be 40 millimeters up. Oh, that's too far. Try 30. That's better. All right, and I think I'm about done there. Oh, that's right. Not quite done. I don't want these ones or these ones because of the way the cavities are going to slide. It would have to slide this way and run over one of them. So I'm going to right click, edit the feature, go down here to instances to skip. So my blue field here, and notice the purple buttons here. I'm going to click on that one. I'm going to click on this one. So now it's not going to make those. And there they go. Okay, next, going to sketch again on here. And all I'm going to do is make an L. And on top of that, a center line. And now I just need to dimension it. Okay, I want that to be 15. And it's going to be 7 up from the edge here. And then I'm going to dimension around that central axis. I want it to be 15. Oh, I'm sorry, actually I want it to be 12. And I want this point to be dimensioned. Remember, this is going to be where our shaft has to fit through. The shaft is a square 6 millimeters, so I want this to be at least 7 to give it some clearance. And then this here is going to be 15 from the edge. Okay, exit sketch. I'm going to click on that sketch and go back to features, extruded boss base, and we'll make it, well, let's see. The actual part is 10 millimeters in diameter, so we'll make sure that this covers at least that, 12 millimeters. And then the thickness, that's also a good 2 millimeters, so we're good with that. Now I wanted to make a plane using that line, but it didn't give it to me. So all I need to do is right click on it, click on show here. So now I can use that center line. I'm going to make reference geometry plane. I'm going to pick that line. Then I'm going to pick this face. And yep, that's what I want. That's my mirror plane. And then with features up, I go to mirror. And it already picked out that plane, so that was nice. Just going to mirror that one feature. And I'm good to go. Okay, now I'm going to take that plane and I'm going to hide it. I'm going to take that sketch. I'm going to hide it then. Okay, so that should be good enough for our screwdriver. The last two major features going to be the draft and then the shell. So click on draft, and I want any surface that the tool is going to hang on to be drafted. So first though, it'll make me pick a neutral plane. So I can pick this plane, and that's the plane that is going to kind of bend about. And notice this direction should help us to know how it's going to do that. So this kind of tilts it in. So I think I'm going to switch it up, tilt it the other direction. And what faces do I want to draft? This one, and that one, that one, that one, then this one, and this one. Any of those faces are where our main tools are going to contact. Oh, we want 5 degrees on that. And let's see if it makes it. Sometimes it gives us troubles. Aha! Did exactly as we wanted. See the slope? That should hopefully allow us to keep those parts on there. And there's the slope of the one for the crescent wrench. And then if I change how things look, I can see here the slope that is put in for our screwdriver. Okay. And our last major feature will be the shell. It's fairly simple. Click on shell, and you might not want a 10 millimeter thick shell. So we're going to put in 3, and we only need one surface shelled. Sometimes it can get a little crazy and difficult, but here showing the preview, it's not showing the preview, so maybe it won't work, but it did anyway. So it made sure that this entire surface on the inside here is 3 millimeters from any other external surface, and then it did the same thing here. The shell combined with the draft is going to be somewhat troublesome for the fillets. So probably to start off with, the best way to fillet this is to go here and then simply click this face. There will be a whole lot of fillets that are made this way, and instead of 10 millimeters, which would be bad, aha, I can actually do them. Got 1 millimeter there. So many of the fillets are created just doing that. The ones that are related to the inside geometry here are especially difficult. Go to fillet again. Go there, go there, and now it's making a liar out of me. Those were particularly easy. I'm going to fill it again. I didn't like that for a radius of 1 millimeter. So I'm going to clear that out. Go here. Go here. Uh-oh, didn't like that. So I'm going to delete that. Okay, now there are many other surfaces. The ones up top here, some of the other ones, this one, and so on. So I will leave that to the student to complete, and you are also encouraged to create some form of connection or something that could be molded in as well if you want to, that would allow for uh, hanging on or otherwise mounting on a wall or a pegboard. Notice that if you introduce holes here, those can't actually be injection molded into the simple right and left half cavities. So you'd have to do something a little bit more creative than simply put a hole in. So I'll leave that to your devices. So in summary, this is specifically an injection molded part. According to that design intent, we keep nice thin walls everywhere, including up here. And to work towards a cheap one, we wanted the injection mold just to be able to come out towards us here and away from us there, or in this case, to the left and to the right. So we had to design it so that those two halves of the mold cavity would work that way. And we started also to use a whole bunch of thin features, this one, and this one, to keep that certain thickness and make our design just that much easier. We also extruded a big thick boss here. We had to take care of that later, as well as that smaller one. And there's that thin feature. Then we made a linear pattern that way, and then a linear pattern of the linear pattern and the extrusion. Then we did another mirror of a thin feature, and then we used a draft. Now often we use drafts for molding or casting. This time I used it as a design element to make sure that the things we are hanging on this board are going to stay on the board. Then we added the shell here because this big thick piece of plastic, or for that matter this one, may not do very well in an injection molding process, but if we have it hollowed out, then we have nice thin walls that the plastic can flow through. Speaking of flow, plastic flows much better when fillets are made. So put many fillets and rounds into this board, and also we don't want too many sharp edges because hands are going to be near this part as well. Well, this is the last part for the tools, and I hope that this helped.